Okay, good morning everyone. So, it is my pleasure to be here giving this Gyan course on spintronics, memory, physics and technology. Usually I found the students in India to be very cooperative with the professor. They ask question, they interact. So, I want the same interaction from you. Okay. Usually the energy the teachers get is from you, okay. The energy we get is coming from you. So, if you pay attention, ask lot of question, then we also get excited, then we teach more, okay. So, I would like to ask you all to ask questions, listen attentively, and with that let me get into the discussion today. So, this module is roughly going to be this way. So, we will have so roughly around 10% of this course will be the introductory stuff. Then we will move on to learn the fundamentals of magnetism, because magnetism is the fundamental needed for spintronics. Then I will touch upon magnetic recording, because magnetic recording is the parent technology for spintronics. So, if you ask me where the spintronics field is coming from, it is all coming from magnetic recording. So, people do research on hard disk drive and they invent so many things. All these are the founding seeds of the spintronics research that we are doing these days. Okay. So, I will touch upon magnetic recording a bit, then we will move on to the magnetic memory. Then towards the end we will learn some of the emerging technologies like today Professor Datta was mentioning, like neuromorphic computing, all these kind of things we will learn towards the end. Okay, why this module? Actually this slide was prepared for Singapore audience, but it's actually for anyone. So, if you know that the electronics industry is also picking up in India. So, there are a few plants coming up in Gujarat, and I heard that there is also some plants, semiconductor plants coming up in Assam and so on. So, semiconductor technology is a vital technology for all of us. The mobiles we use, the laptops we use, the memory we use, all are coming from the semiconductor technology. So, without semiconductor technology you cannot imagine how our life will be. Okay. So, it is very important concept, and as I mentioned early today, the semiconductor technology is also facing some limits. So, we cannot keep on increasing the processor size forever. So, the semiconductor technology is looking at alternatives. So, in that sense the spintronics field is very important. Okay. So, spintronics technology is supposed to extend the life of semiconductor technology. Okay. So, because of that this course is important. So, if you are here to learn some pure physics, then this is not the course for you. We are not teaching any pure physics here. In this course you will learn a bit of material science, how materials play a role in advancing the semiconductor spintronics technology, and how we can apply the material science principles to design the memory aspects for spintronics, and you will learn some applied physics, and I will also touch upon some electrical engineering concepts. So, by training I am not an electrical engineer, so I am a physicist, but I have some exposure to material science, electrical engineering and so on. Okay. So, these are the stuff that you will learn in this module. Okay. So, as I mentioned, interaction is very important, and I always feel very happy to talk to the student from India, because you all ask a lot of questions. So, in this course I will also ask a lot of questions. Okay. So, I will use this app Ooklap. So, I will flash some questions. So, some of the questions will be of multiple choice. So, you just have to choose A, B, C, D. So, some case you may have to choose only one answer. So, for example, A may be right, C may be wrong. So, you just choose A, then you gave the correct answer. Some questions A, B, C, D, maybe there may be one or more right answers. Okay. So, based on the question that I flash, you may have to answer, either choose one or choose many. So, it is up to the question and the answer you think. Then there are also some questions where you may have to type in your answer. Okay. So, always keep your mobile ready, and when question comes up you just choose the answer or type in your answer. Okay, so I can see like how many have joined as of now, like looks like 48 of you have joined. Okay, let us start with this question as a trial. Why did you choose this course, for example? So, when you see this red light coming up, it means the question session is going to end. Okay, after you answer, I can basically flash. So, probably some of you have written, I want to learn gain spintronic knowledge or something like that. So, word cloud is usually a bit messy, but other questions you can see, like I will show you later. Okay. So, from tomorrow onwards there will be a coherent story every day, one topic, but today it will be like scattered. Okay. So, it is like when you start cooking, what you do, you first collect the vegetables, you wash, maybe you peel the skin, then you cut the vegetables and keep it ready for cooking, right. So, today's session is like washing the vegetables, cutting the vegetables and keep it ready for cooking. So, whatever you are going to learn today are some of the miscellaneous things that we do not I mean things that do not fit into the regular flow of things. Okay. So, today is some kind of preparatory lectures that we will have. So, the first question today is name the first information storage system that the human beings have ever used. I want more answers, so I increased the time. Okay, many of you, I mean the words that look big are the majority of the answers. Okay, so many of you have chosen diary, so some of you have chosen calculator, some of you have written brain. Okay, so this is the answer that I expect. Okay, brain is the first information storage that the humans used. Okay, so since time memorial, we use our brain to know where we can get food, where a lion or something is going to come, where a predator is coming, so where we can hide. So all this information, I mean which food we can eat, which food is poisonous, so all those information from our life in caves and so on. So we used to remember everything using our brain. So that is the first information system that we used. But brain is not enough, right? So if I teach you so many concepts, you cannot take all the concepts in your brain, so you need to take notes. So right now we are taking notes in iPad or paper, but in the past people have used various other kind of information storage systems. So for example, people used clay to imprint letters, used rocks. Paper was invented in China, then people used palm leaf. Then when the computers came in, people used punch cards. Then people started using magnetic tapes, then magnetic drum, then followed by hard disk drive, floppy drive, and so many things. Okay, CD, now you use USB drive and so on. Okay, so all those information storage systems evolved because we need to somehow store the information. We cannot remember all the information, we need to store the information, so we need some storage systems. So that is why we invented so many other storage systems. Okay, so that is one point. To emphasize the second point, let me play this video. Okay, you can laugh. Okay, no need to like keep controlled. So what does this video tell you? Yeah, so when information goes from one person to the other person, there is loss of information. So traditionally our Indian system is not good. So we, let us say for example, we had a sloka or whatsoever, right? We never had a system of recording things on paper or anything. So we passed information from one generation to another generation just by asking people to recite. Okay, sometimes the information will get twisted. On the other hand, if you have like a Chinese system, you have a paper where information is recorded, then the information does not get lost. Okay, that is another point. Thirdly, like suppose you want to describe something, let us say you go as a tourist to say Italy, you see something, then you come and tell your friend that I saw this, I saw that. Okay, you will tell something, but your friend will picturize something else. Okay, the information past will be different. On the other hand, these days, you know, we all have Instagram, so many things. You produce reel, then your friend sees what exactly you saw. Okay, so these are all the importance of information storage systems. Okay, so they help you to remember, store the information, they help you to pass the information correctly from one person to the other person, even if it is visual. Okay, So, because of all these reasons we need to look at the storage and memory systems. So, we have moved away from paper tapes to floppy disk, CD, USB drive. Now, we store information in clouds also. Okay. For example, you shoot video, store it in YouTube. So, where is your video stored? It is stored somewhere in cloud. Okay. So, cloud is basically 80% hard disk drive and 20% semiconductor storage devices. So, because of all these reasons, it is good to know some working principles of magnetic recording based on hard disk drive, because whatever we store information, 80% of it is stored in hard disk drives. So, when I started teaching this course like 20 years ago, I wanted to show the students that the data grows every year. Okay. So, what I did, I just count the space used by my emails and I showed them that information grows every year. Okay. But these days you are all very familiar with the Facebook, YouTube, Instagram and so on. So, every day you shoot photos, upload to Instagram, shoot reels or shoot videos, upload them to Instagram, YouTube and so on. So, every day so many people are doing this. So, the information keeps growing. So, we need to come up with systems that can store all this information. So, this is an old slide, but as of 2018 about 10 power 21 bytes of information, I mean hard disk drives were shipped with a capacity of 10 power 21 bytes, but we are worried that we might generate more information than the capacity that can be stored by the hard disk drives. Okay. So, because of this reason we always want to improve the hard disk drives, and increasing the capacity of hard disk drives comes from spintronics principle. Okay. So, spintronics plays a very important role in how do we enhance the capacity of the hard disk drives. So, when I was like you, the hard disk drive I buy used to have like 1 gigabyte capacity. Okay. So, now you can easily buy 10 terabytes. 10 terabytes is like a 10,000 times larger capacity than what I used to buy in your age. Okay. So, this kind of capacity increase of the hard disk drives has come mainly from spintronics. And as I mentioned, we generate lots of information, and a few years ago most of the phones used to have like a DVD kind of video, but now most of the phones have 4K USD or some phones have 8K USD. So, when you have this kind of capacity, basically you are generating, suppose you want to store 1 hour of uncompressed video in 8K USD format, you are generating 86 terabyte. Okay. So, all these things that we generate need lot of storage. So, that is where the storage is important, and memory anyway we are going to learn. So, memory is also important. So, quite often people get confused between what is memory, what is storage. Okay. So, people all think the USB drive you use is memory or storage. What is it? Storage. Yeah, the pen drive you use is a storage device, it is not a memory device. So, you can understand the difference between memory and storage by looking at the next few slides. Suppose you have an exam tomorrow. Okay, you have an exam tomorrow, say quantum mechanics exam, then you are studying for the exam tonight. As usual, we all study just day before the exam, right? Then, so your desk will be filled with probably the quantum mechanics notes. Okay, nothing else will be on your desk. Okay. So, memory is like your desk. So, you keep the data that you need for your immediate work. Okay. So, that is the memory. So, in computer we have CPU, then we have memory. Memory is where the data that you want for your immediate computation is stored. On the other hand, hard disk drive or your pen drive or whatever storage device that you use is like the bookshelf or cabinet. Okay. So, you need all these books or files for your future but you don't need them today. Tomorrow your examination is on quantum mechanics, so you don't need all this stuff. So but you need them for some other time. Okay, so you store them somewhere else, right? So the hard disk or the pen drive, all these things are like the bookshelf or cabinets. So depending on which is immediately needed, which is not needed immediately, we have a hierarchy in the computing systems. So if you look at the computer, you know that there is a CPU that does the computing, and the CPU fetches the information from cache memory. So this is a kind of memory. So whatever is very quickly needed, the information will be in cache, and if something is not that urgently needed, that's stored in random access memory. Suppose you are doing some computation, but say you also want your computer to store some movies which you don't need to watch, because tomorrow you have quantum examination. Okay, so you don't want to watch the movie, so the movie is stored somewhere in hard disk drive. Okay, so this is how the computing hierarchy look like. Whatever is immediately needed by CPU is closer. So CPU is the one that does the processing, cache is closer to the CPU, RAM is a bit far, hard disk drive is far, and the time needed also is like it takes around 10 milliseconds to fetch the data from hard disk drive, and if you look at the cache, it needs only 10 nanoseconds. Okay, so you can see that if the computer wants some information quickly, the CPU wants some information quickly, it wants to fetch from cache rather than from hard disk drive. And this also affects the cost. Okay, for example, hard disk drive can store a lot of information and it's very inexpensive. On the other hand, the cache memory or random access memory, they are expensive. So this is how the data is stored in your computers or in your mobile phone. Okay, let's do some questions. Okay, you can see the question, right? Okay, so this is how the results look like. So usually if most answers are, I mean if there is a wide distribution, right, for example like 33% answer this one, 33% answer this one, say 20% answer this one, 10% answer this one, that means the concept is not clear. But if majority of you answer one, most likely you are right. It is very unlikely that all of you are wrong. Okay, but so usually when I see a histogram like this, I don't need to spend much time because most of you have answered correctly. So in this case, the correct answer is the best CPU. Okay, so you only need lot of computing power. You don't need to spend too much money on memory. Okay, so this is the correct answer. Next question. I think you can see the question in your phone. Okay, so here your supervisor asks you to do a job that handles and generates a lot of data. So in that case you need both good CPU and a good memory. Okay. Also you need the best hard disk drive because you need to store lots of data. Okay. So there will be some questions like this where you need to choose 2 or 3 answers. Okay. So depending on the question you choose as many as possible. I mean based on what you think is the right answer, choose. Okay, let us skip some questions. Now let us move on to the hard disk drive. So as I mentioned before, hard disk drive is the one where 80% of the data is stored today. Okay, so you might tell me that your computer or laptop doesn't have a hard disk drive. Okay, my laptop doesn't have a hard disk drive, or this Apple computer doesn't have a hard disk drive, but still we use a lot of hard disk drives for storing our information, because as I mentioned before, if you upload some video to YouTube, so Google stores your videos in some data center. So in a data center 80% of the data is stored in hard disk drive. Okay. So if the data is not urgently needed, the data will be stored in hard disk drives. But some for example, you take banks also store information in clouds. So banks may need the data for, suppose you want to draw money or you want to use phone pay someone money, so that information has to be like brought very fast. Okay, those kind of information will be stored in solid state drives. Okay, so hard disk drives, as I mentioned, they are very important because 80% of our data is stored in hard disk drives. And hard disk drives were invented in mid 1950s. IBM International Business Machines, they invented hard disk drives in 1956. Since then it has been used in computers, and somewhere in 2000s it was also used in consumer electronics. So many of you might have seen, might be using iPhone. So before iPhone there was a product called iPod. Okay, I don't know how many of you have seen this. Okay, this is a music player. So before this we used to have like a tape recorders and so on, but this iPod was a revolutionary product because it came with a hard disk drive. At that time the small hard disk drive inside this iPod was storing 30 gigabyte of information. So with the 30 gigabyte of information you can store like thousands of songs, which was a revolutionary at that time. You know, this was like 2005, that kind of time. So consumer electronics, it was they were also using a lot of hard disk drives. So there were video recorders which were using hard disk drives to store information, and even now Xbox uses hard disk drives. So when you play games, the games are stored in the hard disk drives of the Xbox. And now you have home cloud, you also have other cloud like Amazon, YouTube, Facebook kind of cloud. You can also have a cloud at your home. Okay, you can store information and you can access from anywhere. So all these things store information in hard disk drives. So if you open a hard disk drive, it will look something like this. Okay, so you will have a disk. So this disk is the one that stores the information. Okay, tomorrow I will settle this one. Today I will sit down. Okay, yeah, this disk is the one that stores the information. So in the disk you will have many tracks. Okay, so you look at this one. This is a circular disk. So you can have many concentric circles. So you call each of them as a track, like in a sports ground, you see many tracks, right? So in a similar sense, there are many tracks if you go from outer diameter to the inner diameter of a hard disk drive. So let us say I ask you, like, you go from here to here, say 1 inch. 1 inch is like this distance, right? The one segment of your finger. So you travel 1 inch. How many tracks you think you can find in a current hard disk drive? Roughly this is the size of a hard disk drive. I have hard disk drive, but today I forgot to bring. Tomorrow I will bring a hard disk. So let us say I go from this distance to this distance. How many tracks you think you can find? Give me some number. Millions. Okay, that's very close. We have around 500,000. Okay, so within 1 inch we can find 500,000 tracks. Okay, that. So when you say million tracks in 1 inch, what is the width of the track you expect? Huh? Micrometer? No. Huh? Tens of micrometer. Hundreds of nanometer. Micrometer and hundreds of nanometer. Okay. Yeah, typically right now the tracks are 50 nanometer small. Okay, so this width, the width of one track is only 50 nanometer. So that's the kind of density in which we store information. So remember, the first concept is that in hard disk drive we have many tracks. So in each track we can store many bits. For example, let us say from this line, this white line to this yellow line, let us say this is 1 bit, okay, then another bit and so on. So if you travel along the track, you will find many bits, and we have some number to describe all of them. Okay. So when you talk about some technology, right, you always associate some number with it. So for example, if you go to buy random access memory, you will go to the shop and order, say 8 GB RAM or 16 GB RAM, right. So RAM capacity is expressed in gigabyte. So similarly, when we talk about the tracks or the number of bits that we store in a given distance are expressed using some numbers. So here I show three such numbers. One is the track density. Track density means when you go from one end to the other end, how many tracks you have. So he answered 500,000, right. So if you have 500,000 tracks in 1 inch, so that's like 500,000 tracks per inch or 5 lakh tracks per inch. Okay. So this is one number that we use to define the technology. Okay. So if I ask you 8 GB RAM or 16 GB RAM, which one is better? You know the answer, right? 16 GB RAM is better than 8 GB RAM. So similarly, so we use this number, track density. So whether track density 100,000 tracks per inch or 200,000 tracks per inch, which is better? 200. We want more tracks in a given distance, right. So that we can pack more information. So track density is one number that we use to measure the technology, the growth of technology. The second number we use is the linear density. Linear density means, linear means what? Linear means a straight line. So I go from one end to the other end. So I count the number of bits in a given inch. Okay. So the number of bits in a given inch is called linear density, which means I go from here to here 1 inch, count the number of bits. So that's my linear density. So this is some number we use to define the status of a particular technology. Then the third number we use to define the growth of a hard disk drive is the areal density. So as the name implies, it has something to do with area, the density of bits in a given area. Okay. So you take a square inch. So in 1 square inch, how many bits you have? So that's called the areal density. So why I keep using the word inch is because the hard disk drive technology comes from America. America, they don't use kilometer, they use miles. They don't use centimeter or meter, they use inch, these kind of things. Okay. So since they invented hard disk drive, we have to deal with the inch. Okay. So we express the number of tracks, track density in number of tracks per inch, linear density in number of bits per inch, and areal density. So is a multiplication of linear density and track density. So is again the number of bits in a square inch. So these three numbers are usually in the research area. Common people don't talk about areal density or linear density or the track density. Common people talk in terms of capacity. Okay. So if you go and buy hard disk drive, or you order a hard disk drive from Amazon, for example, then you may order like 1 terabyte, 2 terabyte. Okay. So those numbers 1 terabyte, 2 terabyte, they all represent the capacity of the hard disk drive. Okay. So how much will be the capacity of the hard disk drive? That depends on, so that's a function of, so here what I want to say is capacity is a function of areal density. That means how many bits you can pack in a given area, then the size of the disk. Okay. So this disk can be big or small, so depending on the area of the disk you can store more information. And the third aspect is the number of platters. Okay. So in one hard disk drive you may have 1 disk or 2 disk or 4 disk. So depending on how many disks you have within a hard disk drive, you can increase the capacity. Okay. So people can play with all these things to increase the capacity of the hard disk drive. So I told you that when I was your age, we used to have 1 gigabyte hard disk drive, but now you can buy 10 terabyte hard disk drive. That's mainly coming from this aspect, by increasing the areal density. So previously we used to store, let's say 1 square inch, we used to store maybe like a few thousands of bits. Now we can store like a few terabits per square inch. Okay. So as of now, let me write it here. Okay, again let me settle this tomorrow. So currently the areal density is 1.5 terabit per square inch. So tera is like 10 power 12. So 1.5 times 10 power 12. So that is like 1500 billion bits per square inch. So that is the kind of areal density we have, and that's what we use for storing information in hard disk drives as of now. Yes. Yeah, please. Here.
You have mentioned the number of platters there. So it means the number of disks.
Yeah, number of disks.
So these are arranged in the arrays manner, like one above the other.
Yeah.
So how this reading and writing will be done for the below chart?
Okay. Yeah, this is why I suggested ask question. So when a teacher teaches you, right, the teacher will come up with 100 things to teach, but during the flow we might leave like 20% or 30% out. So unless you ask questions like this, we cannot bring everything. Okay, so thank you. So ask more questions like this. So first question was, what do I mean platter? Platter basically means I mean the disk. Okay, so the number of disk determine the capacity stored by a hard disk drive. The second question is, how do we write or read information from every disk? Okay, so here you see, okay, firstly before I answer that question, I also must say that the disk has two sides, right? So we use both sides to store information. Okay, so there is some set of information stored on the upper surface, and there is also some set of, almost equal number of information stored on the bottom side of the disk. So we use both sides to store information. So it's like writing on both sides of the paper. So sometimes you write on one side, sometimes you write on both sides, right? So when you write on both sides, you store more information. So similarly, we use both sides of the disk to store information. And in this visual, you can see only one arm. So this arm is the one that, okay, this arm moves like this. Okay, this spindle rotates the actuator like this. So this one goes from outer to inner side or inner to outside. So it can rotate like this. At the same time, the disk also will be rotating. So when you have a rotational motion and you have this arc motion of this, you can access the whole area. So that's how you read or write data onto the whole area of the disk. So there is another arm like this at the bottom also. So the bottom side also we have this arm, then there is a head that moves and moves over the bottom surface. Okay. So similarly, if you have like 3 or 4 disks, then you will have like 6 or 8 of them. So each disk has 2 of these actuators. Any other question? Pardon? Whether there is lithography involved in hard disk drive. The disk itself, we don't use lithography. I'll give you some idea of how the disk is made during the next few days, but we don't use lithography for the disk, but for the head that reads or writes information, this small thing, there is some lithography involved. Any other question?
One question from the online participant.
Okay.
From the case one, does linear density is same for inner and outer track as their circumferences are not same? I'm asking.
The number of bits will be different, but the linear density will be more or less same.
Okay, one question from the Solanki, that can we say this is like a spin orbit coupling as analogy?
No. Why spin orbit coupling? No. Okay, I think time being I will say I think no, but I don't know if there is any deeper meaning. Let me come back to this later. But as of now, there is no. The answer is no. Okay, let's do some questions. So I taught you the linear density, track density, these kind of things. Let's do some questions. How do I get rid of the pen? I want to get rid of this.
This pointer.
No, I need to. Okay, I think this now it's okay. Yeah. Okay, most of you are right. So when we measure the track density, we go from say the outer diameter to the inner diameter, count how many tracks we can see in a given inch. That's how we calculate. So 2 is correct answer. Okay, the answer is leaked. Okay, here the answer is leaked. So, but still you can try to calculate. Okay, I would have preferred a board, but we don't have a whiteboard, so I will read. Okay, so 1 meter in 1 meter length, we are seeing 66 megabits, so which means 66 times 10 power 6 bits. Okay, but 1 meter is like 10 power 9 nanometer, right? So 1 billion nanometer is 1 meter. So in 1 billion nanometer, we have 66 megabits. Okay, which means 1 bit will be 1 billion divided by 66 million, so that will be like 15 nanometer. Okay, so the correct answer will be 15, not 50 or 20, 15 is the correct answer. Okay, let's do this one. Okay, I want more answers, so I extended the time. Okay, 2 million is the answer given by many of you. Okay, we can also say 2 megabits per inch. This is also correct. Okay, so since most of you have answered correctly, this is also correct. So I don't need to go through. Next question. Okay, majority of you are right. So 500,000 tracks per inch is the correct answer. For those of you who answered wrongly, so if you want to calculate the answer for this question, so 1 inch is 25.4 millimeter, right? So 25.4 millimeter is 2,540,000 nanometer. So you divide 200,540,000 nanometer by 50.8, you will get 500,000. Okay, so that's how we can calculate the track density. Okay, so for this particular course, I may not cover too much about magnetic recording, but I will give you a flavor of how the magnetic recording works. So, for example, whether we use lithography or we don't use lithography, what do we use, those kind of material science aspect I will touch up on in magnetic recording. Okay. So, it has been more than 1 hour. You want to take a break, maybe 5 minutes, short break. Okay. So, So please come back by 12:05. Now it's 12.